Hi friends, today I am giving a lecture on order of growth of functions in design and analysis of algorithms. First of all, what is order of growth? Order of growth means when the input size of the algorithm increases, then the computation type of the algorithm is also increases. That means the computational time is directly proportional to input size of the algorithm. If the input size of the algorithm is increases, then the computational time of an algorithm is also increases. So there is a directly proportional between computation time of an algorithm and input size of an algorithm. Okay, we can say that order of growth really matters when the input size is very large. The running time of an algorithm mainly depends on input size and the nature of the input. Okay. Order of growth simply provide the behavior of an algorithm. If the algorithm is fast or algorithm is slow or algorithm is average, okay, by using this order of growth we can mention that algorithm is fastest algorithm or slowest algorithm or average algorithm. So that can be mentioned by using order of growth. Next one, suppose we can take a problem. So to solve that problem, we have to use different algorithms. So by using that different algorithms, we have to solve the same problem. Okay, now we have to compare the relative performance of the algorithms for the same problem. For that purpose, we have to use order of growth. Order of growth. Okay. So order of growth can be mentioned in this order. Okay. First one is big O of 1. So big O of 1 is nothing but constant. Next one is big O of log n, that is logarithmic. Next one is big O of n, that is linear. Next one is big O of n log n, that is also logarithmic. Next one is big O of n square, that is quadratic. Next one is big O of n cube, that is cubic. Next one is big O of 2 power n, that is exponential. Next one is big O of n factorial, that is factorial. So the relation between these functions is big O of 1 less than big O of log n, big O of log n less than big O of n, big O of n less than big O of n log n, big O of n log n less than big O of n square, big O of n square less than big O of n cube, big O of n cube less than big O of 2 power n, big O of 2 power n less than big O of n factorial. Okay, by using this order of growth, we can mention the efficiency of an algorithms. So that is which algorithms are efficient algorithms that can be discussed by using the order of growth of functions. Okay, suppose we can see this example table. By using this example table, now this relation is true or false. We can easily know. Suppose n is equal to 1 n is equal to 1, n is equal to 1. So what is the log n value? That is 0. Big O of log n value is 0. N value is 1. 0 less than 1. That is big O of log n less than big O of n. Okay. Next one is, now we go to n value is 4. N is equal to 4. So big O of log n value is 2. 2 less than 4. That is log n less than n. Condition true. Next, 4 less than 8. Big O of n less than big O of n log n. N value is 4. N log n value is 8. 4 less than 8. That is condition true. Next one, big O of log n value is 8 and big O of n square value is 16. Okay, 8 less than 16. Condition is also true. Next, big O of 2 power n. So n is equal to 4. Big O of 2 power 1 n value, that is 2 power 4, that is 16. 16 less than big O of n factorial, that is 24. So 16 less than 24. Condition is also true. So if the n value is increases, so then this condition we have to check big O of log n less than big O of n, big O of n less than big O of n log n, big O of n log n less than big O of n square, big O of n square less than big O of n cube, big O of n cube less than big O of 2 power n, big O of 2 power n less than big O of n factorial. Okay, at some point this condition may have to fail, but after n value is increases, so then this condition is true. Okay, so by using this relation, so suppose we can take n. Okay, so these are the lower bounds and these are all our upper bounds. Okay, so for big O of n, what are the upper bounds are there? Big O of n log n, big O of n square, big O of n cube, big O of 2 power n, big O of n factorial. These all called as upper bounds for big O of n. What are the lower bounds for big O of n? That is big O of 1 and that is big O of log n. Okay. Now consider big O of n square. Okay. What are the upper bounds for big O of n square? Big O of n cube, big O of 2 power n, big O of n factorial. These all called as upper bounds for big O of n square. What are the lower bounds for big O of n square? Big O of 1, big O of log n, big O of n, big O of n log n are the lower bounds for big O of n square. We can take any big O function. Okay. So after that function, what are the available growth of functions are there that can be treated as upper bounds? What are the growth of functions available before that big O function that can be treated as lower bound function? Okay. So by using this relation, we have to find out the upper bounds and lower bounds for a particular function. Okay. Now, so whatever the example we have to follow, that can be shown in this diagram. So in this diagram, in the x-axis, n, that is nothing but input size. In the y-axis, that is growth of function according to the input size. Okay. So this is the log n and this is the n. This is the n log n and this is the n square and this is the n cube and this is 2 power n and this is n factorial. This is plot of function values. Okay. So what are the functions are there? That is log n log n square, n cube, 2 power n, that is n factorial. Okay. So these are the available functions. By considering this example table, we can plot the graph between the input size and growth of functions. So this is the order of growth of functions according to the input size. if the input size is very high, then computational time of the algorithm is also very high. Okay, so this is the description about the order of growth of functions. By using this order of growth of function, we can find out the efficiency of an algorithm. We have to compare the relative performance of the algorithm. We have to decide which algorithm is best, which algorithm is worst, which algorithm is average algorithm. So these tasks can be done by using order of growth of function. So this is the relationship between order of growth of functions. So thank you for watching this video. If you like this video, please subscribe my channel name. So Divyala Srinivasarao. Divyala Srinivasarao. Thank you.